one of the most extensive zones of destruction on planet Earth. Its most visible features are the hundreds of volcanoes that line the shores of the Pacific Ocean. They form an arc which extends 25,000 miles from South America along America's northwest coast to Alaska, and then down through Russia, Japan, and Southeast Asia, all the way to New Zealand. Cataclysmic eruptions have occurred here throughout history. August 1883, Indonesia. The Krakatoa volcano blew itself to pieces, creating the loudest sound in recorded history. June 1991, the Philippines. Mount Pinatubo blasted debris 22 miles into the atmosphere. Suffocating ash swamped over 2,500 square miles. And in May 1980, Mount St. Helens caused $1 billion of damage. The ever-present threat from these volcanoes makes it essential for scientists to understand the forces that power them. The investigation begins here, in Alaska. This land of rugged beauty marks the most northern extreme of the Ring of Fire. 75% of all the volcanoes in the United States are situated in Alaska, making it a perfect laboratory for volcanologists. The first step is to discover how the Ring of Fire's giant volcanoes form.
We're headed to Augustine Volcano, which lies in Cook Inlet, and it's part of the chain of volcanoes that extends all the way down into the Aleutian Islands.
It's a 60-mile journey out across the frigid Alaskan water. In the distance, the volcano soon appears.
There's the Augustine Volcano over there. It's going to be a perfect day to visit.
From high above the clouds, Dr. Bull can gain a clear view of the volcano's distinctive outline. Augustine is a stratovolcano, the type of volcano found all around the Ring of Fire.
Stratovolcanoes are quite unique in that they are shaped as beautiful cones, and Augustine is a perfect example of that.
Augustine last exploded in January 2006, the most recent of 7 eruptions here since 1935. Over the years, solidified lava flows have gradually built up on the volcano's flanks. To investigate what makes these volcanoes so dangerous, Dr. Bull climbs high up on the side of one of these lava flows.
This lava is made up of blocks. There's bits that are a little denser than others, and you can see there's a lot of different pieces to it. So we call this a blocky lava flow.
This blocky lava provides a crucial clue as to why the Ring of Fire volcanoes can be so deadly.
This lava is more thick when it comes out of the volcano, and its thickness will have an effect on how it runs down the slope. The thickness or viscosity of lavas can be shown in a number of ways. Hawaii lavas are quite runny. Honey is a perfect example of that. If you have the volcano putting out Hawaii-like lava, it's going to run quite easily down the rock. Whereas if you have something more like these blocky lavas, they're going to be a little bit more like peanut butter. They'll still run, but the viscosity is much greater.
The viscosity of lava is primarily determined by the amount of silica it contains. Silica is the most abundant mineral in Earth's crust.
The more silica, the thicker or more viscous a lava is likely to be.
Hawaiian lava contains little silica, so it's runny and produces a relatively flat landscape. But Ring of Fire lavas are rich in silica, making them sticky and less able to flow, creating tall, cone-shaped stratovolcanoes. During the 2006 eruption of Augustine, thermal imaging cameras were used to study the volcano. They showed this sticky lava building up layer upon layer. But the thickness of this lava also makes these volcanoes lethal.
Because these volcanoes have lava that is thick, things don't move through them very well. And bubbles of gases can build up.
Deep in the earth, under immense pressure, molten rock called magma contains dissolved gas. But as this magma rises, the pressure decreases. This drop in pressure means bubbles of the gas begin to appear, just like opening a bottle of soda. If the magma is runny, these gases can safely escape. But in sticky, silica-rich Ring of Fire magma, the gases can get trapped, often with terrible consequences.
It's like trying to have a bubble move through peanut butter. It won't happen quite so easily. So there's a lot of pressure that builds up. And once that pressure builds up, it reaches a point where it can't take all that pressure anymore.
The result? Giant explosions caused by the catastrophic buildup of gas inside the molten rock. This is the reason Ring of Fire volcanoes can be so dangerous. But it's not usually the initial explosion that kills. It's what happens next.
Those explosive eruptions can create plumes that go up for tens of miles.
When these plumes run out of energy, they can collapse back down the sides of the volcano in a superheated avalanche of ash and gas. With temperatures of 1,300 degrees Fahrenheit and speeds over 100 miles per hour, these flows destroy everything in their path. A terrifying consequence of the explosive eruptions caused by gases building up inside thick lava. In the next stage of her investigation, Dr. Bull searches for clues as to how this sticky lava forms. On Augustine's lower slopes, she hunts for lava samples from inside the volcano. This giant block of solidified sticky lava was once molten magma deep underground. It was blasted out here during an eruption, and it came with some intriguing evidence.
So what I'm seeing in this rock is a lot of minerals and a little bit in some cases of hornblende.
The presence of these hornblende crystals provides a crucial clue to how the magma formed.
This is important in telling us something about magma conditions where the hornblende crystallized. Hornblende is a mineral that only forms in the presence of water.
These hornblendes show water exists deep in the earth. Scientists suspect this water plays a crucial role in creating the magma that powers volcanoes. Deep underground, rocks are hot and semi-solid. It might seem that the presence of water would cool them down. But that's not what happens. This water, which is under huge pressure, alters the rock's structure and causes them to melt, forming plumes of magma. This molten rock soars up to the surface, building giant volcanoes. Without water causing magma formation deep underground, these Ring of Fire volcanoes would simply not exist.
A lot of this process we're still working on and we don't understand, but there's a fair amount of it that we do. And water has a very significant role in when and how rocks melt.
The investigation into why the Ring of Fire is so dangerous has uncovered two important pieces of evidence. Blocky lava flows are evidence of thick, viscous magma which traps gases inside volcanoes, leading to explosive eruptions. And hornblende crystals reveal that water deep underground encourages the formation of the magma that powers the volcanoes. The geology detectives figure out how this water gets underground and make a remarkable discovery: the chemical signature of microscopic organisms inside the volcanoes. All around the Ring of Fire, explosive magma is forming deep underground, fueled by water. Solving the mystery of where this water comes from is the key to how scientists will figure out why the Ring of Fire is so dangerous. The investigation now turns to Mount Lassen, an active volcano in Northern California. Surrounding the volcano are bubbling hot springs, boiling mud, and volcanic vents called fumaroles, belching superheated steam and gas. All this thermal activity is driven by the immense heat rising from magma deep underground. By sampling the gas coming from these fumaroles, scientists hope to discover the source of the water which causes the magma to form.
This device measures temperature. The temperature of this fumarole is 92.5 degrees C, about 200 degrees Fahrenheit. So just about at the boiling point for this elevation. And that's what we want for a good gas sample, a good boiling fumarole. So you can see what's happening at the surface here, all the steam coming out of the ground, but it's the gases that are along with this steam that we look at closely. And the composition of those gases tell us about what's happening at various depths beneath the ground where we can't see.
Tests on these gases, collected from volcanoes all around the Pacific Ring of Fire, have revealed something surprising. The gases contain carbon-12, a type of carbon that comes from living organisms. The specific levels of C12 found here are the unique signature of tiny sea organisms called phytoplankton. Billions of phytoplankton live in the ocean. As they grow, they absorb carbon-12 into their cells. When they die, they fall to the bottom, forming layers of sediment. In this way, their carbon-12 is transferred to the seafloor. Intriguingly, scientists have found this same carbon-12 pouring out of volcanoes all around the Ring of Fire.
Volcanoes of the Cascade Range have carbon dioxide that's very rich in carbon-12, and it's almost like you're cooking oceanic sediments that are rich in phytoplankton down deep beneath these volcanoes to generate the carbon dioxide you see coming out the top. That links this carbon dioxide to organic sediments way offshore in the ocean. The organic matter that was originally phytoplankton becomes carbon dioxide that we see at the surface.
Seafloor sediments are getting into volcanoes, and these sediments contain seawater. This is the water that causes the rocks to melt below the volcanoes, forming magma. But a mystery remains. The magma plumes feeding the volcanoes lie sometimes hundreds of miles from the ocean. The scientists now have to figure out how the sediments loaded with seawater are moving so far inland. To find out, the investigation heads for Alaska's Chugach Mountains. The research here begins with an analysis of the local rocks.
Oh, this is a really neat boulder that's right here. And what you can see in it is that there's this whole mixture of rock types. You can see that there's this black stuff, which would originally been mud. There's several different colors of kind of greenish rocks, which would be kind of different flavors of volcanics. So here it looks like there's limestone. And I'm going to put some acid here, and if it fizzes, it's limestone. Yep, sure enough, that's what it is. And this would have formed in the ocean. And so this is made up of the bodies of little critters. It got incorporated into this rock, and now it's up here in the Chugach Mountains.
The presence of jumbled oceanic rocks 20 miles from the sea is evidence that something remarkable is happening at the bottom of the ocean.
The fact that you have this mixture of rock types here is evidence for the seafloor moving.
Geologists know that only an enormous process called subduction could shift these mixed ocean sediments here. Subduction occurs when the seafloor moves and slides down under the land. As it descends, the top sediment layers are scraped off by the land like a snowplow scoops up snow. They're pushed up into a huge mound of mixed up rocks. The Chugach Mountains were formed in this way. The seafloor, loaded with water, now continues down into the earth. This is how seawater gets deep underground, where it creates the magma plumes that build the Ring of Fire's explosive volcanoes.
Where we're at right now, the Pacific is subducting beneath us to the northwest at this northern part of the Ring of Fire. It's about 20 miles beneath our feet right here, but if we were to go off that way where the volcanoes are, it's about 60 miles beneath our feet there. And so as it goes to the northwest, it subducts and then brings water and sediment into the earth. That ends up causing melting in the mantle, and then that melt rises as magma to volcanoes.
The investigation to discover how water is getting down below Ring of Fire volcanoes has turned up intriguing clues. Carbon-12 samples indicating that ocean sediments are getting deep below the Ring of Fire's volcanoes. And mixed rocks in the Chugach Mountains, 20 miles inland from the ocean, are evidence that the whole seafloor is on the move, sliding deep under the land. This process is the engine that powers the Ring of Fire's killer volcanoes. But deep underground, the Ring of Fire hides another, even more deadly secret. Earthquakes that can destroy entire cities. The Ring of Fire, a lethal line of volcanoes. 75% of all the volcanoes on the planet. These fiery peaks encircling the Pacific Ocean are built by tremendous forces deep in the earth. Eruptions here have taken many thousands of lives and destroyed billions of dollars of property. But an even bigger killer is present on the Ring of Fire. Earthquakes. 90% of the world's quakes occur in this narrow band around the Pacific, often with disastrous results. Sumatra, September 2009. A giant earthquake left more than 1,000 people dead. Mexico, September 1985. More than 9,000 people were killed by a massive magnitude 8 quake that shook Mexico City. And Alaska, March 1964. North America's greatest ever recorded earthquake near Anchorage. This quake was so powerful, ground movements were observed 4,000 miles away in Florida. Such awesome power drives scientists on to discover why these deadly quakes occur all around the Ring of Fire. The investigation moves to Prince William Sound, 36 miles from the epicenter of the 1964 Alaskan disaster.
We're at the northern edge of the Ring of Fire, and we're going to be looking at evidence for how geologically active this area is today.
Heusler heads for Montague Island, a place that's permanently scarred by the powerful forces which shape this entire region. On land, he finds a rugged, boulder-strewn shoreline.
You can see we're at the edge of the ocean. We're in a high energy environment. There's boulders all over the place. And we're at the top of the beach. Waves have been crashing here and basically getting rid of the little tiny rocks, leaving only boulders behind. And then right here, you can see that these boulders are kind of lined up against each other like dominoes. And so it takes big waves to sort of flip these over and line them up kind of like dominoes like that right here.
But it's not this rocky beach that reveals how violent Ring of Fire quakes can be. The real evidence lies 1/4 of a mile inland. Heusler hunts through the thick undergrowth. Hidden by the trees is a near identical line of boulders.
We've hiked in, thrashed through the alders, the Alaskan jungle up to here. We're probably 25 or 30 feet above sea level at this point. And what we have here is a beach. I mean, this is basically a perfectly preserved, high-energy beach environment like we were looking at down on the shoreline. And you can see here, once again, there's these big boulders that are sort of laid over in this domino-like fashion, sort of pointing uphill as a result of this big waves pounding on the beach, flipping the boulders over, pointing in the uphill direction.
This inland raised shoreline runs for hundreds of yards, parallel with the ocean. It's a key piece of evidence, and it can only mean one thing. The land itself must have recently risen up out of the ocean, taking the entire shoreline with it.
It means that there was an event that was essentially an instant in which this region was uplifted to this elevation and made this here. This has to have been a result of a big earthquake. Really cool. What we're looking at here is a result of the 1964 Great Alaska Earthquake. Pretty much right here where we're at is where there was the largest uplift that occurred.
The massive earthquake here not only lifted the land out of the sea, it also caused a wave of destruction, devastating nearby anchorage.
It was a magnitude 9.2. It was the second largest earthquake ever recorded on Earth. It was just enormous. It lasted 4.5 minutes of ground shaking.
What happened throughout this region offers evidence of the type of quake that makes the Ring of Fire so dangerous.
So we know from this kind of earthquake that occurred here in 1964 that this was a thrust-type earthquake, or even there was a fancy term, megathrust earthquake, because it was so big that occurred right here. And this is a result of the slippage of one piece of rock over another, or one underneath the other.
Megathrust quakes like this are the most powerful on Earth and are one of the great dangers of the Ring of Fire. If they occur under the ocean, they can generate killer waves called tsunamis. The Great Alaskan Earthquake of 1964 caused a tsunami over 200 feet high. Waves traveled over 1,700 miles, claiming lives as far away as California. But this disaster was nothing compared to what happened in 2004. On December 26th, tragedy struck when an enormous underwater megathrust earthquake off the Asian coast generated monster waves. The coastlines of 14 countries were swamped, killing more than 200,000 people. The vast scale of this disaster was a brutal indication of the power of megathrust earthquakes. And it's given urgency to finding out why these quakes happen all around the Ring of Fire. Once again, the Alaskan landscape is the perfect geological laboratory.
So we're headed to a seismic station in south-central Alaska near the tip of the Kenai Peninsula.
Millions of years of the Ring of Fire's volcanic activity and rippling earthquakes have given Alaska an incredibly rugged landscape. It's not easy to find a flat spot to land.
It's clear on my side.
High on the hillside lies West's seismic station, protected under the yellow cover from the elements and the local bears.
So this is the vault where one of our seismic stations lives. This is one of the many seismic stations that dot the state of Alaska.
Several thousand seismic stations like this exist, all the way from Alaska down to California.
This whole system together monitors any kind of seismic activity, any sort of earthquakes throughout this whole area. It's part of a whole network on all of the volcanoes around here, on the mainland, and throughout this whole area. So the seismic data can be used not only to judge the severity of the earthquake, or the magnitude, but also, when taken across a number of stations, to pinpoint the location of that earthquake. In Alaska, we're looking at about 1,500 earthquakes every month. And you take all of those together and you start to see patterns. They map out a ribbon of earthquake activity that follows all along the coast.
This ribbon of earthquake activity extends all around the Ring of Fire. But it is what scientists can see below the surface that is most revealing.
If you look at it from the side, you see that actually the earthquakes that are happening close to the ocean tend to be shallow, but as you go inland, they're deeper. And they create this dipping feature that starts out in the ocean and then dips down beneath the continent.
This giant dipping feature provides conclusive evidence for how the megathrust earthquakes are generated. The earthquake epicenters exactly follow the path taken by the seafloor as it moves down underneath the volcanoes. Earthquakes are triggered as the rocks slide past each other down into the earth. It is this subduction of the seafloor beneath the land which creates the Ring of Fire's lethal megathrust quakes and builds its explosive stratovolcanoes.
So all of these observations, the volcanoes, the line of seismic activity, the big earthquakes at the interface, all of those are part of one system. They all tie together and are interrelated.
The investigation into why the Ring of Fire is prone to such lethal earthquakes reveals a raised shoreline, evidence that the Ring of Fire suffers the most violent megathrust earthquakes. And seismic data shows that these killer quakes are caused by subduction, the movement of the seabed, which also builds the Ring of Fire's giant volcanoes. To discover exactly where this awesome process of subduction occurs, oceanographers search for the deepest and most inaccessible places on the entire planet. The journey to understand why the Pacific Ring of Fire is so volatile has revealed the critical role of subduction, which pushes the seabed deep down into the earth. In Alaska's Prince William Sound, investigators search for where the seafloor is vanishing below the land.
There are ridges, outcrops, canyons, gullies, mountains underwater. And so the ability to make a continuous map of the seafloor, get a full picture of it, gives you the ability to understand how the seafloor is put together and what it has to do with the way the Earth functions.
Reynolds is using high-tech echo-sounding technology to monitor the exact depth of the seafloor. A sound wave is sent from beneath the ship. The time it takes to reach the seafloor and return gives an accurate reading of depth. Reynolds' research shows that all around the Alaskan coast, the seabed is relatively shallow. But farther out towards the open ocean, the readings change dramatically.
So in general, around the world, when you go out from land, you cross over a relatively flat shelf, down the slope and into the deep ocean basin, which is very flat. But around the Ring of Fire, as you go out from land, across the shelf, down the slope, instead of going directly into a flat ocean basin, you go across a very deep trench. These trenches are the deepest areas on the planet, and the one around Alaska reaches approximately 21,000 feet.
These giant features are called subduction trenches. The largest are deep enough to swallow all of Mount Everest. They mark the exact spot where the seafloor disappears down into the earth, the process that jolts the land in megathrust earthquakes and forms the volcanoes that make the Ring of Fire so dangerous.
The Ring of Fire is named for these volcanoes that circle the Pacific Ocean. But offshore of the volcanoes, wherever you have a chain of volcanoes, you also have one of these deep ocean trenches.
The location and shape of the Ring of Fire is determined not by its famous volcanoes, but by the position of these deep subduction trenches miles out in the ocean. And by mapping the location of all the trenches in the Pacific Ocean, scientists have made a further, even more significant discovery. High-tech imaging has made it possible for scientists to visualize the Earth drained of its oceans. This reveals that these deep trenches outline the edge of a giant rock slab, or plate, that makes up the entire floor of the Pacific Ocean. This huge Pacific plate is one of 14 plates which cover the entire surface of the planet. Subduction occurs where this plate rubs against one of its neighbors, producing the line of volcanoes which extends all around the Pacific. But the investigation isn't finished. Experts journey to Tiger Mountain in Washington State to figure out how such huge plates can be shifted against each other.
GPS that you use to drive around can tell you where you're at on a city block or on a street to within a meter or so. But in geology, we're interested in centimeter to millimeter accuracy so that we can track the changing of the land. It's much more subtle.
High on the mountainside, Flake has set up a GPS marker point.
Here we are on Tiger Mountain. This is our GPS unit. What we have is these metal rods going into solid bedrock, cemented in so that there's no motion. This GPS antenna allows us to measure point positions per day of where this spot is.
A network of these GPS antennas across North America provides evidence for the monumental forces which power the Ring of Fire.
This is just a single antenna. There's hundreds all across the western United States to give us a better picture of what's going on with the ground surface. By combining all the data of these GPS, we're able to see that North America is actually moving.
The entire continent is moving westwards at about 3 inches per year. This movement is possible because the Earth's crust rides upon a hot, soft layer of rock called the mantle.
Well, the mantle is so hot and it's such a high pressure, and the temperature is hotter as you get towards the center of the Earth. That's going to want to move out and convect, just like a boiling pot of water. And so it creates a convection current coming up to the surface, which then drags along those plates on top.
These phenomenal convection currents force the Pacific Plate into its neighbors, driving the process of subduction.
As the plates get dragged by the mantle convection currents, they impede upon other plates. One has to give, so one dives down underneath another, and then the trapped water from its ocean sediment escapes and melts the upper lying mantle, and that creates hot magma that rises to the surface and creates the volcanoes that form around the Ring of Fire.
The investigation into the forces that drive the Ring of Fire has now found subduction trenches that reveal the shape of the entire Pacific Plate, and GPS data providing evidence for the convection currents which force this giant plate against its neighbors. It is this movement of the entire Pacific Plate and the resulting subduction of the seafloor down the trenches that shapes and builds the Ring of Fire. But one final mystery remains. Vast sections of the seafloor are constantly being destroyed. But despite millions of years of subduction down these trenches, the planet's seafloors have never been eradicated. The geology detectives can now reveal why. All around the Ring of Fire, enormous volcanoes dot a landscape warped by violent earthquakes. Geologists could only assume one thing. Somewhere far out in the ocean, volcanic activity must be creating new seafloor rocks, replacing those destroyed here during subduction. Beginning in 1977, a series of expeditions set out to investigate where this occurred. Scientists realized that if volcanic activity was constructing new seabed, the surrounding water should be warm. The Alvin submersible was equipped with high-tech sensors to discover where this warm water existed. To begin with, the crew searched the seafloor without any luck. But then they hit the jackpot. A column of rock pumping out superheated water. This is a black smoker. Measurements of the water around these features have found temperatures in excess of 750 degrees Fahrenheit. This heat comes from magma welling up from inside the planet. It was a discovery that provided the evidence the scientists needed. These volcanic marvels mark the location of giant features called mid-ocean ridges. At these ridges, on the bottom of the ocean, powerful convection currents in the mantle separate Earth's plates, allowing lava to spill out onto the seabed.
New oceanic crust is constantly being formed out on the mid-ocean ridges. That crust moves away from those ridges toward the edge of the continents where we're located now.
In this way, the seafloor is constantly renewed, replacing material destroyed by subduction at the edges of the ocean. These mid-ocean ridges exist at the bottom of every ocean on Earth. They provide a never-ending supply of new rock, keeping alive the entire plate tectonic cycle.
Well, this is a planetary scale process. This is the planet itself circulating, and the rock and the magma from deep inside the Earth welling up to the surface, forming this crust. And then that crust dives back down into the Earth at the subduction zones, at the trenches. And it's mixed back into the solid Earth.
So great is the power driving this system that experts see no end to the constant movement of plates around the planet.
The forces involved with plate tectonics caused by the heating from the inner core of the Earth is so astronomical that there is nothing that will stop it.
It seems like the Ring of Fire will go on for some period of time. It looks as if we've been having subduction here underneath southern Alaska on the order of 200 million years. And it looks like there's no evidence that's going to stop anytime soon.
But over the coming billions of years, the ongoing movement of plates will redraw the map of the world.
The Pacific Plate is moving, and things on it ride with the plates that are being subducted. So, for example, the Hawaiian Islands are moving up here to Alaska. Parts of California are moving up here to Alaska. Baja California is moving north here to Alaska. So apparently Alaska's a popular place to be. It'll be the resting place of all these things.
So the map of the Pacific will slowly change, driven by the immense force of subduction. This is the real story of the Ring of Fire. Subduction creates the magma plumes which build the region's explosive volcanoes. Subduction powers the violent megathrust earthquakes that shake the region, leveling whole cities in seconds, and causing killer tsunamis.
This process of subduction just releases an enormous amount of energy through both earthquakes, through building these mountains, through volcanoes. It's just really inconceivably huge.
This is what makes the Ring of Fire the most geologically active and most deadly place on the entire planet.
You see the whole picture of creation and destruction of a plate in the Pacific Ocean. And the Ring of Fire is the boundary of that cycle, and it's the place where all the destruction is happening.
Geology detectives have now pieced together the evidence for what makes the Ring of Fire so dangerous and discovered what powers it. Violent eruptions of explosive blocky lava build the Ring of Fire's famous volcanoes. Mixed rocks from the seafloor found miles inland are evidence for the process of subduction that builds the volcanoes. Raised shorelines are evidence for giant megathrust earthquakes caused deep underground by subduction. And GPS plots provide evidence for the immense convection currents deep in the Earth which drive the entire system. These giant forces have built the Ring of Fire.
The energy that drives this whole convective system is really without parallel on the Earth. There's nothing else that we can compare to as far as the amount of energy and the force that moves the continents around, compresses them against one another, drags one down beneath the other. Really just awesome force.